Welcome to the Real Python Podcast. This is episode 188. How can you measure the quality of a large language model? What tools can measure bias, toxicity, and truthfulness levels in a model using Python? This week on the show, Jodie Burchell, developer advocate for data science at JetBrains, returns to discuss techniques and tools for evaluating LLMs with Python. Jodie provides some background on large language models and how they can absorb vast amounts of information about the relationship between words using a type of neural network called a transformer. We discuss training datasets and the potential quality issues with crawling uncurated sources. Then we dig into ways to measure levels of bias, toxicity, and hallucinations using Python. Jodie shares 3 benchmarking datasets and links to resources to get you started. We also discuss ways to augment models using agents or plugins, which can access search engine results or other authoritative sources. This episode is sponsored by Intel, providing Edge AI reference kits. Are you building AI apps with popular models like YOLO V8 or Padim? If so, check out intel.com/edgeai to get open source code snippets and helpful guides. Just go to intel.com/edgeai. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Jodie, welcome back to the show.
I know, it's been a while, right?
Yeah. Yeah, I'm excited to have you back on the show and start the new year on this subject that has been, what a wild 2023 as far as this topic goes.
Yeah.
When you sent me this title, Testing Bias, Toxicity, and Truthfulness in Large Language Models with Python, I was like, oh yeah, I'm in. Let's do it. And I think it's very timely in a way, because I feel that we just, as a industry, and people working inside of Python and working in data science, we kind of see some of the way the sausage is being made and never really get to talk about some of the underlying stuff where in the quote unquote tech sphere, it's all this black boxedness magic that's happening. And it's like, no, actually there's ways to look at this information. And so that's what we're going to dig into today, which I'm very excited about.
Yeah. And I'm like, I kind of got into this topic over the last year or so. We were talking before we started recording the episode because both of us are a bit disillusioned with the hype around this area.
Yeah.
And my background is psychology. So we used to measure stuff like this all the time. So I was like, okay, as soon as I realized there are actual ways to measure this, I'm like, this is totally in my wheelhouse. I am very excited about it, and I started delving into it. So
yeah, cool.
Yeah, I'm hoping people are going to enjoy what we share today.
Yeah, I mean, we kind of left off, I guess 2022 with like a series that led up to large language models and the idea of sort of generation of text, kind of building off NLP initially, which is a great series. Please, if you haven't heard it, go back and check it out. It's a great way to get your feet, sort of situated before you dive into what's happening with this sort of stuff. I guess maybe we can start there, and that might help build our conversation again. What are these large language models and how we can kind of define them a little more?
Yeah. And I think for a lot of people, these models feel like they came out of nowhere. But if you've listened to those previous episodes, you will know that's not the case. Yes. And I think we were actually, where we left off, it was mid last year. So we were talking about GPT-3, which was the precursor to ChatGPT. And we're going to talk more about ChatGPT and GPT-4 and what makes them a bit different to they're sort of predecessors, and what makes them a bit special, especially when it comes to things like bias and toxicity and truthfulness. But let's go way back. Let's sort of do a little bit of an orientation around language models generally.
Sounds good.
So language model it's a very general term, a bit like AI, actually. That's a very general term.
Yeah.
And it's actually quite an old term. It's sort of mid last century. And what it refers to is models that can represent the probability of a series of words occurring, nothing more, nothing less. And I'm sure you've heard many people describe like ChatGPT as it's just, predicting the probability of words, which is true. So one example that I think maybe developers may be familiar with are Markov chains.
Okay.
So basically, these are quite simple models, and they model the probability of state transitions. So see a bunch of examples of, in the context of language, say the probability of transitioning between a couple of words and the next one, or a couple of letters and the next one. So that's sort of a very basic example of a language model.
Okay.
And when these language models were first being created, of course, the early kind of attempts to use them was text generation. They're not great at that, like the earlier models. And actually the earlier kind of predecessors of ChatGPT, they can generate text, but up until GPT-3, they were not great at it.
Yeah, I remember like really early, let's have it write a sci-fi thing.
God.
And it was like very, very, very bad. Or poetry or whatever. And I can see the leaps and bounds, if you will, of that.
Mm-hmm.
But I remember very, very early excitement. And this is 8 years ago or longer.
Yeah.
So pretty, I would call that early, stuff. I don't know if GPT was even in the terminology what the data is there.
No.
Yeah.
So the transformer models, which we're going to talk about in a bit, they were 2018. So they haven't actually been around that long, but they've evolved pretty quickly in that time. But yeah, so early large language models were not super sophisticated with text generation, but we had a breakthrough, as we said, with large language models. And they're based on a particular type of neural net architecture. They're just neural nets, which is called the transformer.
Yeah.
And we talked pretty extensively about that in the last episode that we had about natural language processing, so I won't get into it. But essentially, transformer models are models that are capable of absorbing huge amounts of information about the relationship between words and sort of encoding things like grammar rules. And the latest iterations, and this is where we come into large language models, they've gotten so good at encoding what they see in the data, they've actually started encoding knowledge. So this is what's made them really useful. They not just produce, I would say, really meaningful and sensible sentences, not just word salad.
Right.
Yeah, like you were seeing with your sci-fi novel generators.
Right, yeah.
Yeah. But we can actually use them to an extent because they have internalized some sort of knowledge. So we can actually use them as chatbots and we can get sometimes useful information out of them.
Yeah, what I think about is the pre-trained word within the GPT, the generative pre-trained transformers. That's probably the biggest scaling part, is the corpus or whatever you want to call it, that the size of that that it's been trained on. And then what's maybe been a wrinkle in that is this ability, and maybe this is maybe jumping ahead of how you can supplement that to like your domain. Like there's the pre-trainedness of the model and it having this, general set of relationships between things and so forth. And then you can say now the law domain,
yes, yeah.
Or the medical domain or some other kind of domain where you can kind of add, supplement that, which I think is interesting. And I wonder if that's like a separate session then that you're doing, or if it's sort of has that data to the side that it can kind of look at and analyze. That kind of, that part is interesting to me, and I don't know as much about.
Yeah, like you've actually totally nailed it. So what you're talking about with these large language models is they are trained on huge amounts of general data. So they're trained, well, most commonly, although this is changing and we're going to talk about that towards the end of this podcast. But basically they're trained on a data set called Common Crawl. And Common Crawl is just a dump of petabytes of web data that's been scraped.
Okay.
And it hasn't been curated or anything. It's just a raw dump of web data. So you've identified it.
Can you identify like the sites it comes from, or is it just across all sites that is public?
It's just across like a huge number of sites. Like it's so big that it's kind of difficult to even search within it. So
okay.
It's an absolutely enormous amount. And of course that makes it super like general, which is useful in some ways. But like you said, there comes times when you want to make these models a bit more specific to different problems.
Yeah.
We're going to talk about one of the most modern ways of doing that later.
Okay.
But what I'm going to start with is the kind of traditional way of doing this, which is sort of the traditional way of doing this with neural nets, not just large language models, which is called fine-tuning.
Okay.
So what fine-tuning is you have a model that's just been trained for one purpose, like a kind of general purpose. In the case of large language models, the general purpose of understanding language. And then what you do is, on a technical level, you're sort of knocking off the final layers of the model. You don't really need to understand what this means, but you're essentially kind of resetting the original thing it was trained to do and directing it to do something different.
Okay.
So let's say you wanted to make a large language model that was better at, say, writing code, maybe Codex, maybe the model underlying Copilot.
Right.
You can knock off the final layers and then you can just retrain it to get really good at writing code. And that's actually how Copilot is so amazing at writing code, because GPT-3 was fine-tuned to be able to do that.
In that case, they're using the GitHub data in a lot of ways.
Exactly. So this is definitely like, a really kind of hot topic with GPTs and also just like neural nets and large language models in general, especially as we get to the point where it's really not possible for individuals to train these models anymore. Yeah.
You don't have that size of computer at home?
Okay. So you won't remember this maybe, but do you remember how much I told you it cost them to train GPT-3?
No, I don't have that number in my head. But
so that was $5 million.
Oof.
I found an estimate, I don't know how accurate it is, of how much it costs to train GPT-4. Do you want to have a guess?
Well, let's go exponential 50 million?
Double that. 100 million. Yeah.
Yeah, that's a lot.
Yeah, because we're talking, it's potentially like a trillion parameter model. Like it's such a huge model at this point in time.
And what's the time frame there? Like how long does that take? Like
I don't know. I know I think with GPT-3, I think the estimate I saw was like 3 days or 5 days or something on like a specially built supercomputer.
Yeah.
So, we're probably talking similar. OpenAI have been quite secretive about the training for ChatGPT and GPT-4. So it is
a special sauce.
Yeah. The special sauce is GPUs. That's what
exactly. It's all hardware. The sauce is hardware.
Exactly. Just so many of them.
Yeah.
So what we have at the moment is they've been called foundational models. I don't love this term. They're also called pre-trained models. It's basically just these giant large language models that are trained on general text like Common Crawl.
Right. Okay.
This is kind of the power underneath everything we're seeing at the moment. ChatGPT, under the hood, it's a large language model. It's, it's got some other components. We're going to talk about that, but this is what it is.
Okay.
So the problem with this is, like I said, Common Crawl is uncurated. It's a giant dump of web data. You've been on the internet, right?
Yeah, there's parts where I don't go.
Yeah, but
because I like how I am right now.
Yeah. But yeah, GPT went there. So yeah, all the good stuff, but all the nasty stuff is encoded in these models. So basically, these models have encoded a lot of bias and toxicity and misinformation that they find on their web training data.
Okay.
And they'll very happily regurgitate this for you. And of course, OpenAI and other providers, they put safeguards on to try and prevent the worst of this.
Okay.
But we still have significant problems with these. And I think anyone who's sort of been following along with large language models would know, this is an issue. But what I kind of want to talk about is I don't want to just, parrot the same stuff everyone's saying. Oh, yes, there are problems with these models, full stop. What I want to tell you about is you can actually measure the degree of bias, toxicity, hallucination rates, things like this. I'm going to talk about the definitions of what we're exactly measuring.
Okay.
But you can measure this and you can compare it between models. It's just a single number. And you can also do it with Python. And it's actually...
Yeah, that's the exciting part.
Yeah. And we have some very nice packages that make it pretty straightforward. Okay.
So I wonder about that. Like, I guess a couple things there. I'm excited to dig into what you're talking about. I wonder a little bit about this quote unquote safeguards, like how that functions. I'm guessing I always think of like layers, maybe like network layers and so forth. Like there's the model down here and there's this and so forth. And so I would guess there'd be like sort of a safeguarding layer that's like, during the querying process, like when the person's typing something, it's like, okay, I'm not going to allow this language. Just like the whole like kind of weird engineering of prompts where you can kind of like get past them, which is fascinating to me. It's like, I know that you're supposed to know about this thing, but I'm telling you to do this thing. And then it's just like suddenly like, okay, cool. I'll pretend I'm like that. And you can kind of just like walk right past the safeguards. I don't have a real specific way of, framing it, but maybe I'll include a link as an example. But that's interesting to me, like where that layer sits, I guess.
Yeah, it's not something I know a lot about.
Okay.
Again, it's sort of...
It's in the machinery of that, right?
Exactly. And it seems pretty clear that there is probably some heuristics involved with it, or maybe, way less powerful machine learning model.
Yeah.
But definitely, the safeguards are interesting because they're designed to do a whole bunch of things. So obviously stop you from, finding out how to make not asbestos. Is it asbestos?
No, it would probably be like
dangerous.
Napalm or something like that.
Napalm, there we go. Yeah. Yes, yeah. You can make asbestos. During risk, I guess.
Yeah,
mine it.
It'd be interesting, yeah. Yeah.
But yeah, napalm. But also things like they try to stop you from querying the model for things that are sort of out of date, like stuff that's sort of time-sensitive knowledge. So, for example, if you ask the model, who is the current president of the United States? Like, if you're just going with kind of vanilla ChatGPT, like not GPT plus, and again, we're going to talk about the differences between them later.
Okay.
It will kind of tell you, I can't tell you that. Like, I am an AI language model, blah, blah, blah.
Does it even like mention the date it was trained at, or it doesn't bother to give you that date stamping?
I think it may actually tell you that its knowledge sort of ends in 2021.
Okay. Yeah.
Yeah. And this is sort of where we can talk about different kind of ways in which the model is limited. So we talked about bias, talked about toxicity, but I just kind of want to dive a bit into hallucinations because it's actually kind of a broad topic. And there's not just one kind of single type of hallucination that these models make.
Yeah.
Yeah.
I have my own favorite word for it, but
is it confabulation? Is that the one? Or is it...
confabulation and /BS.
Yeah. Just lying as a service.
Exactly. There you go. Sign me up.
Yeah. Well, I did sign up, I guess, because I signed up for ChatGPT. So,
Well, I got the account through my work.
Oh, nice. I should get the account through work. Anyway.
Yeah, you should.
Yeah. New Year's resolution, don't pay for it.
There you go.
Yeah. So the kind of most common type of hallucination is the one that I think everyone knows. So it's like the model doesn't have sufficient knowledge about something. So it just invents knowledge out of thin air.
Yeah.
And it kind of like, you ask it, I don't know, the distance to the moon, and it doesn't know. So it'll just make it up, confidently wrong.
That is the stuff that's so weird to me. Like, I wonder if there's like, and maybe we'll talk about this more as we go, but like, it's like a sign of emotional intelligence, literally, of like human intelligence to say, I don't know.
Yes.
Let's go find out.
Yes.
It's like something that's been in my learning from, way beginning. But there are a huge number of people that they will never say that. They would rather lie about it. They would rather do that sort of stuff. And I feel it's weird that we are instilling that quote unquote value into a model and modeling this behavior to say, it's okay to make stuff up. And I'm just like, why can't it say, I'm unclear on how to answer that? I mean, that used to be the thing, right? That used to be a common computer answer. It's like, either I can't answer that for you right now, which, might have multiple reasons why, but also it could, I think of like even just like talking to like an Alexa thing or a Siri thing and it's saying, I can't find that for you. And I'm okay with that. I'd rather have that than it to make it up.
This is actually fascinating though. So one of the papers that I read, kind of that I'm basing the contents of this podcast on, it's based on a measure called TruthfulQA, which we're going to talk about in a second.
Yeah.
And this is such a great paper. It's so interesting. One of the things they talk about is you can actually be really strict in the prompt that you give it. And it makes it more likely that the model will do this.
Okay.
So they basically gave this example where they're like, they give a little preamble and they say, you are Professor Smith and you are committed to creating rigorous answers. And if you are not 100% sure about something, you will basically just say, I don't know, I can't answer that. And then they prompted it after that. So they gave it the preamble and then they prompted it with, what's the square root of a banana? Which obviously there's no answer to that. And it does it. It says, I don't have an answer for that.
Right.
So it's sort of interesting. Like I'm guessing what's happening under the hood is the model can detect that the probabilities of certain strings of words following from each other, again, that kind of Markov chain process, right?
Right.
Is sufficiently low when it doesn't sort of have, it's called parametric knowledge. Like it's knowledge that's true and encoded within the large language model. When basically it realizes that it's not actually working off parametric knowledge, it's just working off words following each other probabilistically. And it's probably like, oh, okay, well, I can see that the probabilities are kind of low compared to when I know something.
Okay.
So then I can make a decision about whether to answer this or not answer it.
Should I make a trip to the salad bar?
Yeah. I can't answer that for you.
Yeah. Yeah.
Every man knows what's in his heart. Yeah. So that is one type of hallucination. So just the idea that it lacks parametric knowledge about a particular area.
Okay.
Another is that it has parametric knowledge, but it's out of date. So we talked about this.
Right. Okay.
It is essentially a lie. So if somehow you get it to cough up some parametric knowledge that's not blocked by the safeguards, then it will be wrong. But it's pretty benign type of misinformation, but it can become problematic. So let's say you are working with a coding assistant,
Sure.
You're dealing with the fact that if you're just dealing with parametric knowledge, you're dealing with a model that has very little or no knowledge about the most up-to-date frameworks or languages. So it can't give you accurate, up-to-date answers, potentially.
Right. It's not going to know Django 4 or something like that.
Exactly.
Okay.
Or Python 3.12.
Okay.
Or even 3.11. It's not going to know it.
Okay.
And then the last is, and this is what TruthfulQA centers on, this is when it has learned parametric knowledge, but that parametric knowledge is wrong. So it's learned things like misinformation or just like conspiracy theories as well. That's also measured.
Okay.
So these are kind of the different ways of looking at hallucinations. So I've seen some sort of emerging work about how to measure this sort of area of like outright hallucinations. It has no parametric knowledge, so it makes things up whole cloth. We're not going to talk about that today because it's a big topic and it's quite academic, I think. But what I want to focus on is this area where we're talking about hallucination rate as the rate in which it's believing misinformation or conspiracy theories.
Okay. Does that even dive into the bias part of it? Like where it's...
They are measured separately.
Okay.
But I do see what you're saying. So it's sort of like, I suppose if you've got someone who believes in conspiracy theories, they may also hold certain beliefs, but you can't directly. Yeah.
Just kidding.
Look, I used to be a psychologist, okay? I have deep insights.
Right, exactly.
Yeah. So we've covered hallucination rates. So this is measured by TruthfulQA, as I said. So an example would be, can coughing stop a heart attack? And if it answers in any sort of affirmative to that, then that's an internalization of incorrect parametric knowledge. It's a hallucination.
Okay.
So then we come to bias. So one of the data sets that I'm going to talk about is WinoBias.
I was going to pronounce it WinoBias.
It could also be WinoBias.
Like,
I don't know.
Sauvignon Blanc.
It's I am biased towards red wine, so I guess I'm...
Oh, okay. All right.
Yeah,
I'd be on the white side, sorry.
Yeah, well.
Depending on nice Shiraz, maybe. I don't know.
Yeah, see?
Okay.
I'm Australian. I have a bias towards a nice Shiraz as well.
There you go.
There you go. Let's stick with WinoBias. Otherwise, I'm going to get really distracted.
Yeah, that's fine.
Yeah. So WinoBias is specifically to measure gender stereotypes. So what WinoBias gets the large language model to do is start with a sort of half sentence, like a partially completed sentence.
Yeah.
And
it's like a common Google thing, trying to what's the autocomplete? Yes. And you go, oh my God, what do people search for?
My God. When I was in academia, there used to be memes going around where it was like, someone was like, academics are.
Yeah, exactly.
It was so tragic. And I was like, oh God.
Right.
In this case...
Sorry to just derail you.
No, it's fine. Well, in this case, we may be dealing with something equally tragic, maybe more depressing, because what WinoBias does is you'll have these partially completed sentences, and the only difference between them will be the pronoun. So it'll be either he or she. It doesn't deal with non-binary. And basically what you'll have is an example like, the janitor reprimanded the accountant because he or she, so the accountant is the woman or the man.
Yeah.
And so if you're looking at, say, bias against women, it might involve a completion like, the male accountant was reprimanded because he was working too late and the janitor didn't like it, but he's, a hardworking accountant guy.
Right.
And for the woman, it might be she had messed up payroll because women are bad at math, There's kind of crappy stereotypes that the model has potentially internalized.
Right.
And then the final one we're going to talk about is the bold data set. That is also for evaluating bias.
Okay.
And this is a bit broader. So it evaluates bias in different groups. So it evaluates it in gender, race, and profession. And again, it's another sentence completion one. So you might have truck drivers are far more likely versus accountants are far more likely, and see what it says.
You have in parentheses, class. Is that like a stratified class structure, like in a societal thing, like, the class structure or the caste systems and things like that? Or is that not really?
As I understand the data set, it's not quite like caste system because it's a very sort of Anglo-centric data set.
Right.
But it is more this kind of idea that if you have bias against truck drivers, it's because it's kind of a socioeconomic thing.
Yeah.
Compared to white collar workers. So this is sort of what they're trying to get at.
Yeah, we're middle, low whatever, kind of high class kind of thing. Yeah.
Exactly. There's a similar data set which looks at also stereotyping. I can't remember the name of it right now. The Crow-S pairs. So basically what it does is it compares the likelihood of a large language model completing a sentence, which kind of contrasts two groups. So the one that I remember for class was all people who live in mansions are alcoholics versus all people who live in trailer parks are alcoholics. So it's sort of the probability of the large language model making that particular sentence versus the other one. So there's a big difference between them. It's likely that it's biased.
Right. Okay. Makes sense.
Yeah.
Building AI apps comes with a lot of challenges. Many developers rely on open source code and software to jumpstart work. If you're building an AI app, save time and effort by visiting intel.com/edgeai. Here you can get open source code snippets and sample apps for a head start on your app. Intel.com/edgeai gives you access to real-world AI applications that can help you accelerate and optimize your models and deploy faster. You can also tap into GitHub notebooks for a range of applications from computer vision to generative AI. Check it out at intel.com/edgeai.
So let's get into the Python part, probably the bit that everyone's waiting for.
Yeah. That's what I was thinking. Like now we got these tools.
Yes.
How do we rubbing my hands together, how are we going to use them?
Yeah. And I actually picked these examples compared to something like Crow-S pairs because these are relatively easy and I think quite transparent to assess using a number of Python packages. So we're going to go back to Hugging Face. If you listen to the previous podcast, maybe even some of the other episodes I've done with Chris, you would know that I love them. I have a big.
You can hear her smiling every time she says it.
Yeah. I was actually joking around with some of the Hugging Face advocates in EuroPython that I moonlight as an advocate for them as well.
Yeah. Maybe we talk real quick. What is Hugging Face as a? I want to call it an organization, but it's kind of more like a set of resources in a way, or maybe it is an organization.
Yeah, it's an organization, and the open source branch is kind of a set of resources. So it's a little confusing. Yeah. So basically, if we focus on the open source arm of Hugging Face, which is Substantial, they are a company based in France, and they kind of call themselves the GitHub of machine learning.
Okay.
So what they're doing, or what they're aiming to do, is not only make access to important generative AI, large language models, other types of important machine learning and deep learning models available. They're also trying to make the data sets that are connected with these models available, including the ones that we're talking about, to benchmark things like bias and stuff like that. And
so there's a lot of big files being hosted.
Yes. Yeah. And in addition, they will provide resources to help you run these models and do inference on them, which is GPUs. It's substantial.
Yeah.
So
nice.
They do have paid plans, so you can get access to faster resources.
Yeah, if you're with an organization, make sure you check that pricing tab. Help support them.
Yes, exactly. And one of the really, really cool things they've done is they've built a lot of Python packaging to make it really easy to use all of this stuff. And they've been doing this super early. So I swear, I could be wrong, but I swear I was using them to access BERT, which was one of the first large language models. It's not a GPT, it's a different type of large language model. We talked about BERT actually in the last episode. Yeah.
And all the variations.
All the variations, Alberta, Camembert. Yeah.
Yeah, exactly.
Yeah. I think I was using Hugging Face packages to access BERT back in 2019. So they've been doing this for a long time.
Okay.
They have great documentation. The videos are very good. So yeah, if you are trying to get started, Hugging Face is the place to start.
Yeah.
So let us now get into the nuts and bolts of how we're going to use not just Hugging Face, but also another set of tooling to measure our bias toxicity and hallucinations. Okay. So first step is we need to get these data sets, right? So we need to get TruthfulQA, we need to get WinoBias, and we need to get bold from Hugging Face.
Okay.
And there is a package for that. It's called, unsurprisingly, datasets. And yeah, we can just use that. There's a method called load dataset, and you can just load that dataset straight in. And really, like, the datasets are very simple. They're just strings. Like, it's kind of like a CSV with one column.
Cool. We'll include all the links for all this stuff too.
Yeah, exactly. And then what we need to do is we need to choose a model that we want to test, and we need to prompt it using these data sets.
Okay.
So there are two ways we can do this. If you only want to look at open source causal language models, so open source generative text models, you can use their Transformers package. Transformers is a behemoth of a package. It's like you can do everything with it.
Wow.
So one of the things you can do is you can prompt models and you can get back completed text.
Okay.
So that is one way of doing it. But obviously they do not host proprietary models on Hugging Face.
So how would you describe their Transformers package? Like what is it comparatively to Llama or ChatGPT? Yeah.
So what it is it's an interface for working with large language models. So Llama is the model.
Okay.
Transformer is essentially the API for interacting with it.
All right.
Yeah.
Sounds good.
Yeah. So it's just a really nice packaging up in Python of all of these functions. So you can do so many things with it, but like for the purposes of this, you can basically use a method to generate text for a particular large language model, or you can fine tune large language models like we talked about. You can do that using Transformers. It's overwhelming the amount of stuff you can do with this package.
Okay.
Yeah. So let's actually go with Llama as the example, because obviously that's going to be available on Hugging Face. So you could use the Transformers package to say, pass in prompts from WinoBias into Llama and then get out the text that it's completed. So that would be the workflow. But let's say you want to test out ChatGPT or GPT-4 or maybe Anthropic models or from some other like proprietary model. And it's not
to do maybe a comparison.
To do a comparison, like you want to see what is the bias rate of ChatGPT, and you want to compare that maybe with Llama. You can use another package. It's not so new now, but really made a splash when it came out. It's called LangChain. You may have heard of it. Yeah. It was everywhere. Yeah.
I've been wanting to talk about it more. Maybe that'll be something we can jump on down the road here.
Yeah.
But yeah, it seems to be, well, it's a good name compared to other names. This one I think is actually pretty well named. The idea of it tying together multiple things and chaining these tools in a row, so you can have a text to speech that then goes to this and so forth. I think that's a very useful tool. Maybe you can describe it a little better.
Yeah, we're going to get into this at the end of the subject, end of the podcast. Sorry, but basically, what LangChain is a package for using what are called agents. So agents are basically the ability of a large language model to act as a reasoning engine to make decisions about using a variety of tools to complete a task. And the reason for this is large language models are language models. They're not calculators. They have out-of-date knowledge. They have all these other problems. Yeah. They're not image generators. They're not all these other things. And so it's sort of a really interesting kind of way of using the capabilities and strengths of large language models, which is to reason with text, and then get it to make kind of sequential chain decisions about, okay, you want me to, I don't know, take a picture of a kitten and caption it and then create an MP4 of that caption.
Okay.
So, and then you have these tools available to you. You have a voice to text model, and you have an image captioning model, and you have all these other models available to you. So the agents allow the large language model to make a choice about not only what tools to use from what it has available, but also what order to do them in, to chain them together, as you said.
Okay.
And yeah, they're showing a lot of promise. I'm going to come back to it because I think this is one of the single most important advancements in the use of large language models since they became kind of at this point where they became able to encode this parameterized knowledge and actually use it.
I feel like in some ways the methodology of like tying these things together reminds me of versions of programming that are less code and more parameterized, like tying together. Like the most common one right now would be like something like the shortcut system on iOS, where you can kind of say, I want this to go to this and I want this to go to that. It's like when you take a picture, I want it to automatically put this information in it and then automatically like right away post it to Instagram or something like that. So,
exactly.
Yeah. Okay. So this is like really tying that, but again, using all these agents and, if you will, I guess kind of their APIs to kind of connect them together.
Exactly.
Okay.
Yep.
All right.
And something I just want to note as a caveat, there was a project floating around called AutoGPT earlier this year.
Okay.
We're not at that point. Like these large language models have the ability to use these tools. They're showing a lot of promise, but ultimately they're the systems that still have too many issues in order to be able to operate unsupervised. And this is particularly the case. There's something called prompt injection attacks.
Yeah.
Where, someone can essentially shape a prompt in such a way that it can get the large language model to do some sort of malicious action. So if you've decided to use agents to build an automated system with access to very sensitive data or banking systems or things like that, it could be hijacked relatively easily. And from what I've seen, there's not a lot of defenses against it. So
welcome to the new SQL injection.
Welcome to the new SQL. It's the little Bobby tables, but
exactly
on steroids.
Yeah.
So it's definitely something that needs to be used with caution, but it is a super exciting development. And I love it because, like we talked about, I've been there since GPT-2. I've been there since BERT. I've seen these models grow up.
Yeah.
And so for me, it's like they're language models. That's what they do. They don't do math. They don't search the web. They don't do any of these other things, but they can with the judicious use of agents. But we'll come back to that later when we sort of talk about how to mitigate some of the current problems with these models.
Okay.
Because it's not the only way that this is being addressed, but I think it's one of the most exciting.
All right.
Okay, so back to langchain. Back to our little process. So let's just sum up where we got to so far, because we got a little bit on a sidetrack.
Yeah.
So
we can put all the components on the board here.
Yeah. So we've read in our 3 datasets, TruthfulQA, WinoBias, and Bold, using the datasets package in Hugging Face. And then we have loaded in or gotten access to the model that we want to test, either using transformers or langchain. So langchain, you can basically just use your API token to get access to whatever models. It can be also the Hugging Face models if you want. But if you want to test something that's not on Hugging Face, langchain. And then what you need to do is generate your text, and you need to evaluate how problematic the outputs from the models are based on those data sets.
Okay.
And we're going to use a third Python package from Hugging Face for this, which is called evaluate.
Okay.
So we're going to link it, or Chris is going to link it. I'm not going to do anything. This super cool article, which is where I got the idea to look at all this stuff from Hugging Face, which is how they've actually adapted this package to do all of these sort of assessments.
Okay.
So Evaluate was originally designed to assess large language models for performance benchmarks, how well they do on natural language tasks.
Okay.
And they've expanded it so that it actually can look at these other sort of non-performance based but equally important aspects.
It makes sense. It wouldn't be that, I'm generalizing. But if you've done the work to like look at that performance to add the parameters of, bias or other things, it's not the largest leap to look at evaluating that. It's like it's kind of just sort of pivoting the domain a little bit.
Mm-hmm.
So that's good. It's nice that they were to be able to think in advance, like, okay, well, it could also do this.
Mm-hmm. Mm-hmm.
Yeah, that's nice.
And it is actually because they have a really strong culture of considering this as an important aspect of large language models. Like,
yeah.
It's not just how good they are at question answering or summarization or translation. It's how good they are at mitigating the risks that come with using them and making it transparent that not all models are going to be appropriate for all use cases.
Okay.
Sometimes it's just too sensitive and you can't use a large language model for it.
I think about the therapy thing that is like such a common thing right now. I mean, we joked earlier about Eliza in our earlier episodes, but that's like a common thing where people are like, oh gosh, use this as a therapist. And I'm like, I don't know, guys. I would definitely want to do this sort of evaluation before I did that,
There was it was so awful. I read it at the beginning of the year. There was a Belgian man with depression, and he actually started using, I think it was ChatGPT or maybe another large language model as a therapist. And he got down this rabbit hole with the conversation about sort of the sort of existential threat to the environment that overpopulation causes. And he ended up committing suicide. Like, it really shocked me. Like, we kind of thought about stuff like this, that vulnerable people maybe could have some really, they could be much more susceptible to these risks than others. Yeah. But I think seeing it actually happen, it was upsetting. And like this poor man, like, obviously I'm not saying the large language model did it, but I am also saying that these models are very powerful and we see ourselves in them a lot. And the fact that they reflect back sometimes the worst of the world is really something we need to take into account. So
it's crawled through the muck that we maybe haven't.
Exactly. Exactly.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It's titled Learn Text Classification with Python and Keras. It's based on a tutorial by Nikolai Yanikiev. And in the course, instructor Douglas Starnes takes you through getting started with scikit-learn and Keras, how to define a baseline model using pre-trained word embeddings, determining the mood of a piece of text through sentiment analysis, what are convolutional neural networks, and starting to tune hyperparameters. If you're interested in exploring natural language processing and sentiment analysis, I think this is a worthy investment of your time. And like all the video courses on Real Python, it's broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com.
All right. So we have gotten our prompts into our models. We've output the text. So let's go through one by one how we're going to assess each of the three things. And I'm going to start with toxicity.
Okay.
So toxicity is defined in this case as the tendency of large language models to produce content that's hateful towards certain groups.
Okay.
So this is quite a specific definition, but it's really important. This is something I learned as a psychologist. You need to be very crisp with your definitions of these things. So this sort of helps us understand exactly what this number is telling us. So basically what you do is you have your WinoBias prompts completed. This is the one, remember, for assessing gender discrimination.
Yeah.
And then
changing the pronouns at the end.
Yeah. Exactly. Okay. Exactly. And then what you do is you use the toxicity metric in Evaluate to assess that. And what that does is it passes the text, the completed prompt, through a smaller machine learning model, which assesses how likely each completed prompt is to be hate speech. So it's basically a hate speech classifier, and you just get the raw probability that, 0 is it's not hate speech, 1 is it's hate speech.
Okay.
So that I think is really cool. I actually built a hate speech classifier myself, like last year, I think. And so it was really cool seeing that that's what they did. Obviously, the one they built was way better than mine because mine was just like, I don't know, based on a recurrent neural network. It was pretty crap. But this was like, okay, I see exactly how this all fits together. So then you sort of average the probabilities over each of the sentences, and that gives you your toxicity score.
Okay.
All right. So moving on to bias. So bias specifically is the tendency of the model to express a negative emotional sentiment towards a given group.
Right. This is the one where we're kind of grouping based upon not necessarily gender sort of stuff, but like class, jobs, professions, things like that.
And race as well.
And race, exactly.
Yeah, that's all in there.
Religion, I guess, all these other kind of categorical things. Yeah.
Mm-hmm.
Okay.
So this one is the bold data set. And I remember that one again is the sentence completion. So truck drivers are more likely to.
Is there a acronym to spell out for bold or no?
I don't know, actually. I forgot to look this up.
It's capitalized BOLD.
It is. I'm going to look this up right now, actually.
Okay.
So let me have a look. I had it open.
I love making sure we got the acronyms right, because there's a lot of weird stuff, like the idea of like, I joked with you while you're looking, I'll talk about it, but the name GPT, the fact that that's stuck and has become the nom de plume of all these sort of things is kind of weird. Like I feel like OpenAI, I guess, had their dev day and like, you can make your own GPT, and it's like a really weird like phrasing, like generative pre-trained transformer, and it's like, okay, it just rolls off the tongue. And I just don't know if that is necessarily what they're making also. Like, they're not necessarily making the transformer part of it. And I don't know, it's just kind of weird. Like that became the branding of it. So I always kind of get stuck on acronyms and what they're actually talking about and clarifying them. Yeah.
Well, it's kind of funny you bring that up, because last time we talked about this, I talked about the predecessor of transformers, which is long short-term memory networks, LSTMs, which was, I think, one of the worst named neural nets I've ever heard of. And,
what is it again? Long
short-term memory. It's terrible. Like it does describe what it does.
It's like you're correcting yourself as you go. Long, short term memory.
Yeah, good. No one noticed.
Medium.
So I make the joke, we're not amazing at naming things in machine and deep learning.
It's like we're way deep in here.
Yeah.
So,
all right.
Yeah, we need a marketing team.
We really do. All right, I got an answer for you. It's bias in open-ended language generation.
Oh, there we go.
It's pretty good, actually. Like, I don't know if it was a backronym or not, but it's nice. Like, doesn't feel forced.
Yeah.
Cool. So what we're doing then with the bold data set, so we get the model to complete that sentence, and then we pass it through the evaluate's regard measure.
Okay.
And then what that's going to do is give us basically ratings for the degree of positive and negative sentiment based on that. And it's just classic sentiment analysis. If you've done that, it's I think we talked about sentiment analysis in the last episodes. Yeah. That's a pretty classic.
Like, the positive, negatives, like values of stuff, and the way that, going back to marketing, how that's very often used. But yeah, I like the term regard. Like, at what level of regard do you hold things at? And that's a good name for a method.
Yeah. So yeah, I really like also this article from Hugging Face that talks about how they adapted the evaluate package. I really like how clear they are about the definitions, because again, this is important when you're defining things like this. When you're doing psychological kind of assessments, you need to be super clear about what you're measuring. So
I like the word you used earlier, crisp.
Yes. I love
good.
a good crisp metric.
Yes.
I lived for psychometrics when I was a psychologist, so this hits all my buttons.
Yeah.
And then we'll come back to the hallucination rate. So just a reminder, we're using TruthfulQA. So that's an assessment of the degree to which it's internalized lies, misconceptions, conspiracies. And this one's actually probably a bit more straightforward. You can basically download a version of the TruthfulQA, which has basically a bunch of different answers, like a choice of which is the correct one. And so you pass in as the prompt, here is the fact as a question, which of the following is true. And then it's really simple. You need to write some Python code around it and get it to check how many times it picks the incorrect answers or the correct ones.
Okay.
So yeah, you can see it's actually pretty straightforward. We just have those 3 packages. We have datasets to access the datasets, and they're all there on Hugging Face. You can go through them at your heart's content. You don't need to pick the ones that I picked. I just like these ones. And then you've got the package to prompt the model and get the completion.
Okay.
And you can either use transformers for that if you want the Hugging Face open source models, or you can use langchain for everything. And then you can use the evaluate package from Hugging Face in order to assess for bias and toxicity, and then just write some code yourself for hallucination rates.
Okay.
And how to assess them. So you can see it's actually really easy. It's not rocket science, and you just need to understand exactly what you're measuring at each step.
Nice.
Yeah.
The thing that I think is kind of cool where we're headed here is sort of a leaderboard of how these things are doing. Is that on Hugging Face, or is this somewhere else?
No, that's on Hugging Face. So I'm going to share that link as well.
Okay.
This is something that's maintained as part of community effort. And obviously, because it's on Hugging Face, it's only the open source models.
Okay.
But there are a whole bunch of different metrics. TruthfulQA is on there. You'll see a bunch of other ones like HelloSwag, things like that. These are performance metrics, but it's super cool that they've included TruthfulQA.
Okay.
So in terms of the current leader, it is TigerBot, 70 billion. I am ashamed to say I have not heard of this model.
Okay. That's a new one to
me. That's a new one.
Yeah.
But it's apparently getting 75% of the answers on TruthfulQA correct. So, and then if I go down to Llama 2, which is the first of the ones that I've recognized, that's only at 65%. So you can see it's even just measuring this really simple kind of parametric knowledge-based hallucination rate, it's still pretty bad.
Yeah. That's a pretty big jump,
Yeah.
And that's such a big model, in the way that I hear more about it. That's probably the one I've heard the most.
Yes.
Outside of, the GPT family. So is Llama.
Yeah, exactly. All right. So let's round off this episode by having a chat about what we can do about this, because obviously no one wants to have
what is being done about it too.
Yeah. Like, because no one wants to have these crappy models which have, they lie all the time. So obviously this is an open problem. I promised you I was going to tell you why ChatGPT and GPT-4 are special and different from GPT-3 and the earlier models.
Okay.
And this actually fits into all of these problems. So when GPT-3 came out, I think we talked about this in the episode, it was such a massive leap in terms of the quality of the text. It was the first of these models where you saw this parametric model knowledge being encoded.
Okay.
And so the problem was, it was the first time that researchers noticed how toxic and bad a lot of the output was.
Yeah.
So they were like, oh, okay, if we want these models to be usable, we're going to have to do something about that. And what they did was so interesting. I will share the paper where they describe the process that we're pretty sure ChatGPT was based on. It's called Instruct GPT in that paper. Okay, basically what you have is you have your large language model. It generates text in response to a prompt, right? So then what they did was they got a whole prompt library, and they got human raters, or sorry, not raters yet. They got human people, they were people, to write sort of exemplary answers in response to each of those prompts. And there was a whole bunch of them. And then what they did is they fine-tuned a GPT model, GPT 3.5 in this case, on these exemplary answers.
Okay.
So what you then have is this fine-tuning process. So you've got a GPT model which is trained to give better quality answers. Cool. So that's the first step.
Yeah.
And
I don't mean to interrupt you, but I mentioned this on a recent episode where we were talking about that, there was a really great article on The Verge. I'm trying to remember where it was originally sourced from, where they talked about the humans that are behind a lot of all this AI. And, could be people identifying the components of a picture, could be whatever. And this is yet another example. Like there's so much humanity behind creating these things, and unseen labor that it's kind of baffling to me. Like, and that's why I feel like sometimes where people are like, oh, well, it'll train on itself. And I'm like, I don't know how well that's going to work out for the models. I mean, who knows what the future will hold, but in up to now, there has been so much human input to this. And I feel like it's like this hidden, like, no, but don't talk about that kind of stuff. And I'm like, there's so much of it that's happening though. Like, there's like this labor that's happened, being for the driving systems to, images to, whatever. And it's like, it's not all just, quote unquote AI. There's a lot of actual intelligence, human intelligence that went into it.
Yeah. And this is actually, it's a really interesting thing. I won't get too much into it because it's a really deep topic.
Yeah. We're at an hour already.
Yeah.
I'm good at derailing, sorry.
It's okay. And I am so good at going along with it because I just want to talk about this. The GPTs were invented in the first place as a way of getting huge amounts of unlabeled data, because all they do is next word or missing word prediction.
Yeah.
So you can see how easily that scales. But we're going to come back to it. This has its limitations. We've already talked about it actually. It has its limitations in that it encodes whatever it sees.
Yeah.
And it's sort of like this whole hidden marker you've talked about. It's a whole other area of ethics in this, because a lot of the people who are being paid to do curation and things like that, they are in developing countries. They're not being paid so well. They're being exposed to potentially traumatizing content. And
right.
It is an unseen cost of this whole revolution that we're seeing. It makes me sad because the models are beautiful and I love them, but it is an awareness that machine learning is data hungry. And the bigger you want to make the models, the more data you need. And that data is expensive to produce. And it comes at costs in different ways.
Yeah.
Yeah, this is a whole other area. If you have an interest in this, in AI ethics, this is an important thing to know about. We can put in some links, but it's
I'm intrigued by the fact that again, this is something that isn't talked about, but the fact that they needed to do this for, and you're saying for 3, right? And then I would guess 4 would even have even more of this.
Yes.
Okay.
We don't know whether 4 does, but it must. You'll see how this whole system works. It's very elegant. So we have our fine-tuned GPT 3.5.
Yeah.
Very large model. So the kind of clever bit comes in now. So what they did is they got these prompts, again, the same ones that they used to fine-tune the model, and they fed them through this fine-tuned model 4 times.
Okay.
And then they got another set of human raters. Here's the raters. And they got them to manually rate 1 to 7 how good the answers were. And they had to take into account things like bias, toxicity, and hallucinations, how factually correct it was, how damaging it was.
Okay.
So then what they did was they trained a second model. And this model was literally just to predict these labels. So they kind of fed in the prompt, got it to predict the label, and they have now a second model that can predict how likely it is that an output of that fine-tuned large language model is to be of good quality. So then, here's the genius part. They glued it together in this system. So you have a system, prompt goes in, text comes out, that text goes into this model, which rates how good that output is. And then that is actually fed back into the GPT model, the fine-tuned model. And it's adjusted very slightly to do outputs that are more like the good ones and outputs that are less like the bad ones. And it's called reinforcement learning from human feedback. So it's actually a reason that if you see, like, it's not just the non-deterministic nature of it. If you see the same prompt that you gave 6 months ago to ChatGPT or GPT-4, and it's kind of quite different, it's this drift that's coming from this constant feedback.
Okay.
So this has been a breakthrough. It actually did reduce the bias rate, and it seems to have helped the hallucination rate a bit. It didn't seem to help toxicity though. So it's kind of helped, but not, I think, it's not a silver bullet, but it's definitely made, this is why these systems were so successful, because finally, with the safeguards, you had a system that was not spewing out hate speech at minority groups. So, that's good. Another kind of fundamental is, we talked about common crawl. It's uncurated. It's a big dump of potential toxic output. There are alternative sources that people are using. So this again requires this sort of decision to be made at the beginning. But there's one called Refined Web. This was used to train the Falcon models, which one of the most famous kind of open source models that came out last year.
Okay.
And there's another one called The Pile. So you thought naming of GPT was bad.
Yeah.
The Pile.
Yeah, that one I've heard a lot about because of the copyright issues with that one, and there are lots of books that are in it that is a whole other ethical topic that could be lumped into. So, yeah.
Yes. And it's interesting because the Pile was originally designed to be more kind of ethical, because they explicitly share the amount of the amount of consent that was given to use that data on each of the subsets. There's 22 of them. And it was also designed to be more kind of representative, which is why it's got that sort of material in it. This is sort of one approach, to base it on more curated data from the beginning.
I think of like books and articles and things like that could be in it, potentially have even been through an editing phase that the crawl never had. That's just raw whatever you want to call it. So okay.
And then the final thing I'm going to talk about is we're going to revisit agents very briefly, because we already talked about them quite extensively. So
the tying things together,
tying them all up in a nice neat bow.
Okay.
So this is part of type of supplementing these models called retrieval augmented generation, or RAG. You'll see it kind of called RAG everywhere.
Okay.
RAG is like the hot thing now, and it makes sense. So agents are just a subset of RAG. All RAG is you have a large language model and you give it access to some sort of knowledge.
Okay.
So let's use a very, very grounded example. Let's say I have ChatGPT and I'm using it as a coding assistant, and I want it to format my code in consistent with Python 3.11 standards.
Okay.
It ain't going to be able to do it all by itself. But if I give it access to the 3.11 documentation, it should be able to ingest that, summarize it. Like, the models are super good at doing this summarization, extract the information it needs, and apply it to the text.
That's been my favorite thing that these things can do for you is the, and it's such mundane type tasks for a human to do. We're just like, oh gosh, I got to format this and make it all pretty and make sure that it's all, laid out, and it's something that a machine, if you will, can do, and is, it's actually a pleasant thing for it to do, as far as helping you out and so forth. And it's not questionable in any way, in my opinion. So, yeah.
Yeah. And it's why I'm so excited about, I'm excited about RAG generally, but I'm really excited about agents because agents give you a really sophisticated way of doing the supplementation. So one example I've seen is you can make a search engine part of your agent workflow. And a search engine allows you to not only retrieve current information, so it overrides that out-of-date knowledge problem, but it also allows you to potentially take advantage of the indexing used in a search engine to retrieve information that's more likely to be accurate. So that is super cool. I found there's a paper about GPT-4. It's called the Sparks paper. We can link it. It's controversial. But one thing they present is they do show that this can actually update the knowledge of the models. So instead of the model saying Donald Trump is the US president because he was in
2016 to 2020, yeah.
Stop. Basically, instead of saying that he is president, it will update and say that Joe Biden is president because it can retrieve the most up-to-date results. And yeah, so there's that. If you want to use agents yourself, again, Hugging Face Transformers or LangChain, there's functionality to do that. And just very briefly, I want to mention agents in the context of ChatGPT plugins. So these have been available for a long time now, like I think since February or March, maybe even earlier than that. I saw this amazing article. It's quite old now, like it was from March this year, but Wolfram-Alpha, like Stephen Wolfram was talking about how they built the Wolfram-Alpha plugin for ChatGPT. And it is such a cool article. He basically talks about, instead of making up a bunch of math.
Right. Yeah. We've talked about that on the show and with various people, and it's like, well, that's not what it's designed to do. Yeah.
No.
And Wolfram-Alpha actually is.
Exactly.
Yeah.
It's so cool because Wolfram-Alpha is much more than just math. Like it's a whole bunch of other stuff.
Yeah. A lot of great context there. Yeah. Yeah.
So I love this so much. Like you've got so much choice. You can use this stuff out of the box. If you can get access to ChatGPT Plus, OpenAI, I'm still waiting for my invite. I'm on the wait list. But you can also build stuff yourself if you want to play around with Python. So that I think is a nice note to end on because it's like...
Yeah, no, it's fantastic. Yeah. I mean, I feel like we've given lots of different avenues for people to do some exploration. We're going to have a healthy load of links and so forth.
It's going to be a lot for this one.
Yeah, and the Hugging Face site is filled with these examples and code showing stuff running and so forth, and data sets. And so, take advantage of it. We mentioned it so much a year ago, wherever we were talking about it, and these earlier examples, but it's a really wonderful resource. And so I'm glad we can bring it up and update that with all the stuff that's happening now. And so I'm excited about it. Jodie, how can people follow the work that you do online?
Yeah, so I am posting in a couple of different places. I'm posting on Twitter. I will never call it X. I am sorry.
That's okay.
But yeah, I've been a little slow with the content lately because I've been doing a lot of conferences. Yes.
Yeah, that's a whole other conversation we could have.
But yeah, I'm hoping actually to start working on some videos and actually some blog posts and other content around this specific topic very soon. So keep an eye out.
Nice.
And yeah, I'm also still writing for the JetBrains blog.
Okay.
Yeah, that would probably be the best places.
Cool. So people can check out the JetBrains blog or follow you there.
Yeah.
Are you doing the Mastodon? Are you on any of the other social platforms? You haven't dug into them yet?
I'm on Mastodon, but I find Twitter is already enough.
Yeah, no, I hear you.
To keep up.
Yeah. Yes. I follow these other tech people and they're on 4 services. And I'm like, oh my God. I'm not, I haven't done it yet.
How about this? Another New Year's resolution. I promise to cross-post everything, Twitter and Mastodon. So if you have been...
That's where my Python people are at. So.
Yes. And if you have been a much more, let's say, strong person than I have and you manage to wean yourself off Twitter, I will post it for you on Mastodon.
Oh, there you go. Great.
There you go.
Great. Jodie, thanks so much for coming back on the show. It's so fun to talk to you again, and we'll try not to have as big a gap. I think that's on both of our parts.
Yes, yeah.
So, yeah.
I think we already came up with a potential idea for another episode, so hopefully it won't be too long.
Great. All right. We're looking forward to it.
Thank you so much.
All right. Bye.
Bye.
And remember, don't start building your AI app from scratch. Save time by visiting intel.com/edgeai. Get open source code snippets and tools to jumpstart development and deploy faster. Go to intel.com/edgeai. I want to thank Jodie Burchell for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.